up till now, we have seen a lot of type of transformations, right? We have seen the modulus function, we have seen certain simple transformation, we have seen certain difficult transformations in terms of interpretation. Now, a very important concept in maths that we must know is the meaning of the greatest integer function. Now, what is a greatest integer function? Now, by definition, what is a greatest integer function? A greatest integer function is the greatest integer less than or equal to x. Okay, given by this box x, it says that greatest integer, okay, integer less than or equal to x. Okay, so now my question to you is that let us look at the function, any general function y equals to fx in its generic form. Okay, now what happens in case I put instead of x, greatest integer function x? So what we are actually looking at is a transformation from y equals to fx to y equals to f of greatest integer function x. Okay, so that's what will happen if I change my x to greatest integer function x. So what do we exactly mean by that? Okay, so say you have x equals to minus half or minus 0.5. Okay, so fx will be f of minus half or minus 0.5, right? But now when I'm transforming x to greatest integer function x, then what will be my greatest integer function x? That is greatest integer function of 0.5, greatest integer less than or equal to x. So what is less than or equal to minus 0.5? The integer will be minus 1. Right? So f of greatest integer function x will not be f of minus half, but it will be f of minus 1. Okay, so that's the difference. Okay, so that will be the basic difference between the original fx and the new transformed fx. Okay, so in that case, what do you think? How will your graph look? What will your graph look like? See, while plotting the graph, what will happen? So we have my both axes are there. So x and y are very well out here. Okay. Now what will happen is that I draw a graph of y equals to fx like this. Okay. So suppose this is my graph of y equals to fx. Okay. And I've just numbered randomly my x axis. Okay. Now what's gonna happen is that so at each x I draw a vertical line. Okay, at each x I draw a vertical line. Okay, so at each break of x I draw a vertical line. Now, so what will happen? What will happen between 0 to minus 1? What will happen between 0 to minus 1? Okay, what will happen between 0 to minus 1? As I said, if say minus 0.5 lies somewhere here, okay, so the f value is equal to f of minus 1, right? So every value between minus 1, between every x value between minus 1 and 0 will actually equal to, the f value will equal to, it will equal to f of minus 1, not 0. It will equal to f of minus 1. Okay, so this horizontal line depicts that. Now what happens to f of anything between 0 and 1? Anything between 0 and 1, so say 0.5, half. Okay, now what is the greatest integer less than or equal to 0.5, it's 0, right? So f of 0.5 will actually equal to f of 0. So everything between 0 and 1 will actually equal to, the f value will equal to f of 0. Okay, so hence I've marked out here. I've marked this, you see this yellow line out here. So all these values will equal to f of 0, which is here on the axis itself. Similarly, between 1 and 2, they will equal to f of 1. They will equal to f of 1. So you understand these circles. Why I've put these circles? Because these circles means that at the value 1, it will be f of 1, right? It will be f of 1. So it's not included in that line. Okay. So at value 2, it will equal to f of 2. So it's not included out here. Okay, so this goes like this. So you'll have a step function just like your under the here it will be under the graph. Okay, it will be under the graph. So for the increasing, it will be under the graph. Now let us look at the e function. Okay, let us look at say y equals to e to the power greatest function, a greatest integer function x. Now we all know what a graph of e looks like, right? Now the graph of e looks like this, correct? The graph of e looks like this. So what will be the graph of e to the power greatest integer function x look like? Now, using the same criteria, what's going to happen is that, first of all, just mark your vertical lines, mark vertical lines at all integer values on the x-axis, because that's what we are concerned about, right? We are concerned about the integer value, because one integer value will be ruling all the rationals between the functional value of the rationals between rationals and irrationals between the integer values. That's what is the greatest integer function. So now again, what will happen is that between 0 and 1, it will equal to the value f0. So it will be 1. Okay, you know that exponential cuts the y-axis at 1, because e to the power 0 equals to 1, right? E to the power 0 equals to 1. So it's gonna cut it out here, okay, at 1. Fine. So this is how it will look like. Again, you'll have the step function. Between 0 and 1, it's going to be the same. Between 1 and 2, it's going to be the same. The value of f1. Between 2 and 3, the value of f2. It's going to take the value of f2 all through. It's going to take the value of f3 all through between 3 and 4, and so on and so forth for the negative side also. So if in total I look at the graph of e to the power more greatest integer function x. So greatest integer function x, my y values will essentially be e1, e0, e1, e2, and so on and so forth, because only integers would be in the power of e, right? So I've just marked them like this. And again, we have already found our step functions starting on the x-axis at 1. Okay, now 1 will not be included in this because 1 is included out here. Okay, f of 1 is here and not at f0. Okay, so it comes, the next step starts here. 2 is not included here because 2 is included here. 3 is not included here because 3 is included here. Okay, so that's how the step function will look like, and that's how the graph will look like. That's what the graph will look like for e to the power e to the power greatest integer function x. Thank you.